Hi, everybody. My name is Jutton.
Hi, I'm Manan.
My name is Heath.
Hi, I'm Josh.
My name is Brandon.
Hi, so we are Team UC Berkeley, and today we're going to be talking about our project in the privacy enhancement technology track and how it relates towards the process of food insecurity. But before we do that, let's go ahead and let's provide a little bit of background information. Could we go to the next slide, please? So first, let's talk about the team. So we're a team of undergraduate students from UC Berkeley who are passionate about data science and its applications, and we're a part of a nonprofit organization called Educate. We're dedicated towards data science education for K-12 students and for also the research that goes into making this a reality. Let's go to the next slide, please. And our objective in pursuing this datathon was to tie in our work with our organization to the UN Sustainable Development Goals, specifically in the context of high quality food, access to good education, and ultimately just creating a better life. Specifically, we focused on food insecurity, part of the privacy enhancement technologies track, as it's a pressing issue in our region of California, USA. But it's more than that. Berkeley is where we're from, and we love our school. But Berkeley has an immense food insecurity. 39% of undergraduates and 23% of graduates experience food insecurity at UC Berkeley, and 74% of food insecurity for underrepresented minorities, the LGBTQ community, and people who are independent from their families. Not to mention the number of people that are currently affected outside of Berkeley's campus. We're looking at homeless population and a large number of other people that are negatively affected by food insecurity. And that's what inspired our work today. In this presentation, we're going to be talking about three specific topics. We're going to talk about machine learning models. We're going to be talking about how food insecurity relates to education. And we're going to be talking about how food insecurity is impacted by the environment and ultimately relates to climate change. Let's get started.
Within the food insecurity of Berkeley, as you can see in the Contra Costa and Solano counties, there's a large proportion of red and purple dots, which represent convenience stores and gas stations, which are unhealthier options for the residents of Berkeley as compared to the blue places, which are grocery stores and other places where residents can get healthier foods. As we can see, there are a large number of food swamps within this entire region, which truly inspired us to really focus on the food insecurity within Berkeley as well.
From there, we also wanted to make sure that we took into account the private data, but also that we looked at public data to gain a greater understanding of depth when looking at the data. So we started by looking at the private data and noticed that a lot of what we were interested in boiled down to a few key factors: affordability, whether or not you were able to buy the food; availability, whether or not you could get food; quality and safety, how the food was treated and taken care of; and sustainability and adaptation, specifically how it related towards the context of different farming principles and how they related to global warming. All of this was processed into an overall score that we gathered from one of our current data sets that we linked in our GitHub.
And using that information, we actually examined various machine learning models to try to classify the sort of overall food insecurity level of each area. So what we found in doing a heat map analysis was that affordability, availability, and quality and safety were the most predictive. And so by taking the information and chunking it up by food security level, we were able to run different machine learning models, and we found that random forest and XGBoost were the most predictive, each yielding about 83%. And after some fine tuning of the parameters, we got XGBoost to be at about 84%. And this actually provides a powerful tool for predicting a country's food insecurity level based solely on the three factors: affordability, availability, and quality of safety at a specific time.
Now, within food insecurity and education, we can examine that we create a visualization of the time versus the education for survey respondents. This resulted in illustrating that people with less than high school education degrees is much more correlated with the higher food insecurity rates, attributed to the lack of education for the lack of a high-paying job, or resulting in living in a poor community and having reduced access to good quality food, as illustrated by the graph on the left side. We were also able to determine through overlaying the food access and assistance in the United States, resulted in looking at the correlation of children with low access to stores and the National School Lunch Program participants in 2015, which really illustrated how there was a positive correlation between having more children with lower access to scores and more children being able to harness those student lunch programs. Now, examining the food insecurity and education across different parts of the United States, we can see that California, Arizona, and New York have much higher levels of food insecurity because of their various geographic regions and also their populations combined with their economies and the amounts of people who have access to education.
We wanted to talk about food insecurity and climate change analysis. So when we began looking over our data, what we found was that food security was something that was judged based off of those following factors. So we put together various maps in order to understand this. We built visualizations, thanks, shout out to Heath, to build out various levels of understanding food insecurity across the overall world. So if you can see here by looking at the visualizations, those areas in blue are currently more likely to have greater levels of food security, while those in red are more likely to not have as good levels. And furthermore, if we look at sustainability and adaptation, this factor is actually very prevalent towards looking at climate change. What we're rather understanding here is how the rest of the world, when looking at overall food insecurity, is responding to various farming methods and how these farming methods go towards impacting this type of food insecurity and how this impacts climate change. What we can see is that a lot of areas around the world are currently being negatively affected because of this. And this gave us a lot of unique insights that we're going to discuss next into how we were understanding climate change and how it related to food insecurity and how this all related towards the overall geographic makeup. So next, let's go ahead and let's talk about what we actually found. We just covered a lot of information, but it's important that we make sure that we break it down and actually make sense of it. So first, let's talk about the machine learning models. We specifically were taking our core features and boiling it down to understand things, specifically using XGBoost and random forest to predict what areas were most food insecure. Currently, when looking at the overall literature, it was kind of difficult to really find areas that were able to actually do this and properly understand what areas of the world were food insecure. We were able to train a model to 84% accuracy. And using our core factors, we're able to understand what areas are likely to be food insecure, and we can use these factors in the future as the UN progresses in order to understand what areas may become more food insecure in the future. Next, we looked at neural networks and how this related towards the context of education. Specifically, what we analyzed was how low income, poverty, and access to education play a critical role, are basically all affected by food insecurity. When you look at the overall food insecurity of various nations, what you're finding is those who can't eat are not able to perform at the economic level. And this was extremely impactful to us, especially coming from an institution like Berkeley, where you are challenged and forced to work so hard every single day that you need that in order to be able to perform at such an elite level. Lastly, we looked at global warming and how it played a critical role when it came to understanding food insecurity, specifically how people work with the environment and the practices they chose to participate in play a critical role in how food insecurity occurs. In the UN Datathon sets, we were able to look at the livestock set and actually gain a better understanding from looking at the global warming public data about how the environment can play a critical role in working with food insecurity. So for example, if we look at our hash map or the heat map that we created from the United States, what we're able to see is that the East Coast is more food insecure than the West. And this makes sense due to the overall makeup of the environment, as 80% of the population is currently located west in the East, where it's more likely to create greater levels of food insecurity. So ultimately, what we were able to find was core relationships. But more than that, we were also able to take artificial intelligence and machine learning and use it to be able to bridge and gain a unique understanding and further advance the United Nations goals in working with food insecurity in the future.
In this datathon, we built multiple machine learning algorithms to predict food insecurity in various parts of the world. Analyze the relationship between education and food insecurity using neural networks and heat maps, and gain a better understanding of how the geographical environment and country locations affect food insecurity and global warming. Ultimately, we completed this project due to our belief in innovating and using innovative technology to better the world and solve complex problems that nobody else has thought of before. Thank you so much for taking the time to listen to us today.